Hey, how's it going, guys? So here we are. This is Dev Log number 1, just of the OpenFDD project of getting a major overhaul to version 2. And what I want to start talking about maybe on the weekends, because it's kind of a weekend project at the moment, that the most important part of this project is like OpenFDD is an open source knowledge graph for the building. And what we mean by that is data from building automation systems for any technology system in a building is typically very messy and very can be very random, it can differ from contractor to contractor, technician to technician, manufacturer to manufacturer. So device names, point names, even though they'd be the same components in an HVAC system, which is generally consistent, the names of data, how it comes through, is never consistent. So that's what a knowledge graph will do. And in a mechanical context, systems are linked together. Like, for example, there could be a cooling central plant that feeds chilled water to an air handling unit. The air handling unit feeds air to a VAV box, and this VAV box has a sensor measuring the temperature in the zone. So like what a knowledge graph will do is it'll basically link how the relationships of how data is interconnected. So that's what we'll be doing, and we'll be doing the using the brick ontology. So think of it as kind of like DNA for the building. I think this is the most important part of OpenFDD, and like if we can get this part right, that's a huge success just right out of the box. Just that, for me at least, and anything after that is just an add-on of like cool things. But the knowledge graph is kind of very popular in smart building IoT world, and without an ontology, it's it might be lacking, I guess, in the modern world, and this stuff is very kind of time-consuming and can be difficult to set up. So, okay, so let's get into it. So, devlog number 1, you'll have to bear with me that there's no user interface yet. This is just an API at the moment. So this is an API testing tool built into Python Fast API. The framework, so it's just a back-end testing. And in the future, there'll be a UI that will perhaps mimic how a building automation system looks, which will probably be like devlog 8, 9, or 10, I don't know, but we'll get there eventually. So, but at the moment, we just have like a back-end web app testing tool. So this is it. So this is called a Swagger UI that's built into Python Fast API framework. So to get data into our knowledge graph, let's do a BACnet discovery. This will do a post to this BACnet URL to our web app. So I just did a BACnet discovery for this device, and we found a few points in this device, and we brought it in. That'll be in our model, which I'll show you in a second. Here's another device on my test bench, which is a VAV box. So this will also be brought into our data model. So this is just proving that it found a few points. Some are commandable, some are not. That means writable in BACnet. So if we go look at our data model after that, let's view the data model. So this is what it looks like. It's in RDF format. So that is a resource descriptive framework. So that is something that the brick ontology in smart buildings and ASHRAE 223P uses. RDF format was created in the early 2000s for organizing data on the World Wide Web. So we're going to use it because that's what is popular at the moment, and it's cool to use. And another thing you need too is that the Python BACnet stack, Joel Bender, thank you, that he has built RDF BACnet into the BACnet stack, which is something that we can take advantage of right out of the box in OpenFDD. This is what the Backpipes RDF looks like. So we immediately dump data right into RDF. And then this is actually it's turtle syntax. It kind of looks like HTML to me. Like, it's kind of, think of it like that. It's like it's like a syntax that this file uses, which would have a .ttl in which OpenFDD serializes on the back end. So you can actually see your serialized data model grow and expand as you do this. This is also parameters that OpenFDD defines in RDF format. So in some future dev log, I want to see, we'll use OpenMedio, so that's a weather API to get historical weather data, which is really important, can be, to get more accurate weather data from airport weather stations that are close by, versus the building automation sensors, which are known to be very flimsy and inaccurate. And then we'll compare that to higher grade weather stations from a weather station, and OpenFDD will handle that all behind the scenes. Okay, so the next messy part of this is, like, we need to export this in a format that the large language model understands. I just thought of something. So this is, before we get into that, this is actually what the RDF data model looks like in JSON format. That is something the large language models can handle. We have to give our site, we have to give our data model a site, which is a requirement. So I'm just going to say, this will all be on a UI someday. So this, even though this looks kind of funny, this will be like something as easy as a building automation system that I'm hoping for, but we just have to use fast APIs, Swagger at the moment. So I'm just going to give our data model a site called Ben's Test Bench, and the description is test. So I'll execute that, and then we can view our data model again. We should see it. Okay, there it is in RDF format. So that's a brick site. It's Ben's Test Bench. And then we can run this again. Get this to update. So this will something we can update, or we can copy right here, a copy button, and we'll upload that to ChatGPT along with here's a couple other files. So this other file is just some model context that I have in the agents markdown. It just kind of gives ChatGPT, it can be any large language model, just some context of like what to do with it and what it expects back for the OpenFDD on the other side. I was working with ChatGPT at least. And then there might be some other ways that we can improve on this too. Like this is just a concept idea at the moment, but it's pretty cool. Okay, so, and then also, like, we're gonna give it some rules. So we'll get into this later once we get into fault detection. So this is the brick name for a mixed air temperature sensor, and for example, a sensor bounds rule is just saying that this sensor needs to be within 20 and 120 degrees Fahrenheit, which is it's just something to use at the moment, but in the real world application, there should be much smaller bounds, but we're just kind of using it to test out the product at the moment. Okay, so, and then I also have a prompt here that'll be pushed up to GitHub here in a couple minutes. So okay, so I use OpenFDD. We'll paste in JSON, your job, the large language model, keep every field, and basically it'll assign it an equipment name. It'll kind of tell it, you know, how to return a completed JSON back to us, which will feed back into OpenFDD. So like, we're kind of like in the schematic here. So we're like here. We're using in browser-based chat interface to enhance our data model. And then we're actually pulling data out, and then we're going to use AI to tag it for us, and we're going to push it back into the data to the OpenFDD server, and it will apply all the tags to our brick ontology right here. So it's all up to debate, and it can change, but like some people might even be able to do this on the server itself, and maybe that would be a cool feature, I don't know. If you paste in your ChatGPT API key or something, but I just think that's just might be more bells and whistles than we need at the moment. Plus, if this was running behind the firewall on the client's network, they might not like having some server reaching out to the cloud to do this stuff. So I thought maybe it's this person that should be doing that. That's my thought process, at least. Okay, so ChatGPT chugged away on that, and as you can see, it like this raw messy point DA-P, that is a duct static pressure sensor. So the generative AI is really good at this acronym of SA-T, which is Johnson Controls manufacturer lingo, supply air temperature sensor. So generative AI is really efficient at deciphering these points. I think before generative AI, there was some machine learning initiatives at classifying this, but I think that generative AI can outperform machine learning. Like this, ELEC power acronym, it understands that's the electric power sensor in brick type automatically into the ontology we need. So let's just do it. So it finished. We'll copy you. So it automatically knows polling false, because we don't need that for our fault rules, but it also automatically set polling true, which will be just another feature on our data model. Once we start scraping BACnet, it'll start grabbing polling equals true or not. So generative AI is helping us, the humans, at tag, and it did it very fast. Anyone that has had to tag buildings manually, it's very daunting work, and it's not fun. It's not exciting, but when you can have AI do it for you much faster and efficiently, it can turn into something kind of exciting and fun. Okay, so we're up here, and then we have to push that back into OpenFDD. So we just don't have a UI yet, but we're just gonna try and execute that. So here we go. So we updated it. Then we can check and see if our model took again. Let's check it out. So here's our old BACnet data. Okay, so like what ChatGPT did behind the scenes is that this is our label. So it took a brick name right here, and it mapped that to an RDF format to an aux schedule, and it has and it'll also do time series database references, and so we'll get out of there too. So there's a lot that ChatGPT did in that 30 seconds that would take a human perhaps 3 hours to do. Okay, so now we kind of have a model, and then we can check it. This might be something to do in the future, but our check found one site, 2 backend devices, our triplet count, which is a RDF feature. Everything is a triplet, which we'll get into later. Found 231 triplets. Then there's probably a feature we'll have to build into this someday to validate the model through brick ontology a little bit better. So that is it at the moment. And like, you can also run SparkQL, Sparkle, I think they call it. I don't know what the exact proper word of saying that, but like Sparkle, if that's the correct way of saying it, that is the official query language of RDF. So like when we see this data model in RDF, we query this model through a query language called Sparkle, which is a lot more efficient, much more faster and efficient way of just text searching this file. Sometimes AI will cheat and it'll just grep it. It'll just text search it. So if you ever see AI cheating on your data model queries, make sure it's using the correct query language that the data model expects. Okay, so I just want to demo just a couple, like one or two of these. So like, I'm just playing around with, you can have a .sparkle file. So if I upload, this will all be in something on the repo too. So if I execute that, this was maybe we should look at that. So, but this is a .sparkle that's going to query the data model, and it'll return all the bindings for all these points that we queried for. So this is how you'd interact with the ontology through the API. So right now this is a back-end web app. There'll be a feature that you can do it through here too. Like this isn't very human readable, but perhaps there could be a vendor that could interact with OpenFDD on the edge through querying the data model. So that was, where are we? Okay, so I think that is it for today. In the future, we'll get a lot deeper into SparkQL, but at the moment it's working, so I'm kind of happy about that. And I think if anyone wants to test this out, this would be kind of fun to play around with. And like what I am doing repeatedly over and over and over in testing is breaking it and rebuilding it, breaking it and rebuilding it. So this is just a CRUD app. So like the web app can do get, post, patch, and delete. So we can delete our sites. So if I go delete, or hold on, I have to, this is our site ID for Ben's test bench. If I copy that, then delete you. Status, I deleted Ben's site. We can actually test it again. No sites are left. And then we can do a data model reset. So this will blast the data model away, which we wouldn't want to do in production, but we're kind of getting there, one day at a time. So here we go. So, and then if we check our data model again, we're back to nothing. So other than just the bare bones OpenFDD configurations settings. So I think that is it for today. Anyone that wants to test this out in their own BACnet system, maybe there's some researchers or mechanical engineering students or something looking for people to kind of test this out, and then we'll get deeper into SparkQL queries. So if you go to the docs, there'll be a Sparkle cookbook. So like we can kind of build things, start querying our data models, and then see if we get back our expected results. So this is what I think we would want to do, is kind of start here. That in here, like jumping around a whole bunch here, sorry. We kind of want to be thinking from like a mechanical standpoint of like, what sensors do we want to query? What kind of HVAC system is this? If this is a variable volume air handling unit system building, what kind of faults could we create for that? And then we can start making, because everything will be SparkQL driven. Then we'll kind of play around with Grafana and databases, start doing our fault detection engine, and then actually looking back at it in Grafana. So it might take us a really long time to get there, but I think this might be kind of fun, just little by little. So hopefully you guys can follow along. This might be kind of fun. On Sundays, this will be my weekly hobby project, but it'll get above and beyond my little test bench of 2 BACnet devices that aren't even doing anything to a real HVAC system, but I'm mostly using it just for testing purposes. So at some point in time in a community, it would be fun to, let's get these results on a real mechanical system and start doing some cool stuff with it. Also, please join the Discord server. It's in the link. This will all be linked here too, but we'll do some cool stuff little by little. So until the next one, thanks for following along, and I'll see you guys next Sunday.